So in order to find out if your SQL queries are efficient or not, you would want them to process a lot of data. In order to do so, you'll need data, right? So in this video, we'll be generating 5 million rows worth of random data in less than 100 seconds of processing time using just SQL. In the process, we'll be uncovering a lot of interesting SQL tricks. So let's get started. What we are trying to achieve over here is we are trying to build the taxonomy of Udemy. On the Udemy side, when you go on the top section, you will see categories, subcategories, and topics. A category is a global topic, say a software or programming. Basically, it's art, software, business, and whatnot. Subcategory becomes like programming languages, databases, etc. While topic becomes your core languages like Python, JavaScript, and all. So if we would want to store this kind of structure into a relational database, we would need just one table to hold this up. Let's call the table topics. It would have an ID, a name, a parent ID. So this parent ID would point to the same table. It would have a foreign key pointing to the same table, so that we can maintain a parent pointer. And we'll have type. The type would store if it is a category or a subcategory or a topic, right? So our thing that we would be working on is we'd be generating data for 50 categories. Each of the category would have 100 subcategories. Each of the subcategory would have 1000 topics, right? So that's a humongous amount of data, and in all it turns out to be 5,005,050 rows, right? And what we'll be doing is we'll be using just SQL to generate this data. And a very interesting thing, we'll be using the worst or the most dreaded part of SQL, which is join, to do so. So let's jump right into the world of SQL and see this in action. So here what we have is I'm using MySQLite, which is connected to my SQL interface. And now what I'm doing is first we'll create table, which is topics. It would have an ID, which is a primary key auto incremented. It would have a name, which is varchar 256. It has a parent ID integer null. And why is this nullable? Because the parent of a category is nothing, so we would need to handle that case. And then we would have the fourth column, which is type small int, that says 1, that stores value 1 if it is a category, stores value 2 if it is a subcategory, and 3 if it is a topic. We define a foreign key constraint on parent ID that references the same table topics, and we create an index on type, right? Here what we are doing is we are assuming that we have yet another helping table called counters, and what it has is, so counters table is a very simple one. It has one column called ID whose type is character. What it stores is, it stores value from 000 to 999. So it has 1000 rows, it stores value 000 to 999. So I chose 999 because the maximum fan out that we require is along the side of topics, where each subcategory has 1000 topics, right? So given this, what I've done is I've just pre-populated this table for value 000 to 999. Okay, so now what we'll do it is, if I were to, so we'll start with inserting categories into it. So what we have to do is we want to insert, how many? We want to insert 50 categories. So what I'll do it is I'll write an insert. I'll say insert into topics. Oh, I didn't. Let's first create a table. I didn't create the table. Let's first create it. We'll see output. It says completed in 133 basic. Good. So what we'll do it is we'll insert into table. Since ID is auto incremented, we won't need that. We'll be giving name, parent ID, and type. So what we'll do it is, what we would do over here is we would want to pipe the insert and the select statement. So in insert, you can either explicitly specify values that you would want to insert for each row, or you can specify that insert from the select. So what I'll do it is insert into this topic, and I'll pass a select query to this. And what I'll do it is I'll select ID from I'll select Wait, I'll select ID from what? ID from counters, limit 50, because all we want is 50, 50 rows, right? So here I'm selecting ID. What it would do, it is this command. When I do this, output of this command is having just 50 rows from 000 to 049, right? So we'll be using this to create 50 topics. Now when I would want this, so what I want is, I want 3 columns here: name, parent ID and type. So what we definitely know is that ID, so we are selecting ID, counters and 50, sorry, we are selecting ID from counters and in all 50 rows. What I would do is, I would wrap this select into another select and I would specify this thing. So I'm using nested selects so that code becomes a little readable. And so now what we have done is, we have selected ID 50. So this internal query, so sorry, this inner select would fetch 50 rows. And now what we want is, we want this 3 to be over here. Okay, so we want name, parent ID and type over here, right? So we know that since we are inserting just categories, we know that the parent ID of category is null. We know that type of category, so the value of type, if it is a category, is 1, if it is a subcategory then 2, if it is topic then 3. So this is hard coded, null in this. Now what we want to do is, we want to create a name. So how we would do it is, we would just do a simple concatenation of cat hyphen and we'll give ID. That's it. So now what it would do it is, this particular select command output will be, so output of this particular select command is a sort of temporary view that has 50 rows here. Like here, the first row has cat hyphen 000. This 000 comes from this inner query where we are selecting just 50 from 000 to 049. Then the second one is null, third one is 1, right? So I'll be using this thing to create a temporary view that is of the format that we require it to insert within topics. So if I club this insert and select statement into 1, so the output of this select would go into this insert, right? So this way we would be generating 50 categories, right? So now when I execute this category, in the output it says 50 rows affected. So now let's open this topics table and see if it is really inserted or not. So it's loading, it's connected to something. Yeah, so now you see our topic table is populated. So this ID is auto incremented one, name is cat-000, then we have parent ID as null because all of these are categories, and type is set to 1. So we have inserted 50 rows into table, right? Now comes to the next part where we want to insert what? We want to insert subcategories. Similar to how we insert categories, we would be inserting subcategories. So what we would want to do it is, we would want to insert into topics name, parent ID and type. So over here name is okay, so we'll change the prefix to subcat hyphen and ID something. The parent ID is something that would be specific to every subcategory, right? So every category has 100 subcategories. So we'll start by, yeah, so and the type will be 2. Okay. So now what remains is, we want to handle this ID and this parent ID. So what we'll do it is, we know that, so we here over here if we do select, so for every category, for every category we want 100 subcategories. So if I take a join without specifying where clause, it literally matches every single row to every other row of that other table, right? So if I have 2 tables, first one having 3 rows, second one having 5 rows, so I'd be getting a mapping of every row from this table to every other row of the other table. We'll be using this thing. So just to start with a very small example, I'll just use this select, I'll have what I'll do to select star from what? Select star from topics, or rather let's say I have counters as C1 and counters as C2. Instead of doing this, if I use topics as T1 and counters as C2, right? So if I have this and what I select is T1 dot name and C2 dot ID, right? So output of this would be, it would be combining the topic name and ID, right? So for every single topic out there, which is inserted right now, it would map it to all the rows of counters. So if I see over here, the first column name is my topic name. It has 049 mapping to 000, 48 mapping to 000. Similarly, and so on and so forth. I'll have my cat 000 here, my cat 000 mapping to 000 of counter. Similarly, for 049 it maps to 1 and the list goes on and so forth, right? So this is basically n square. So every row of this gets mapped to every other row of this. We'd be using this very thing in order to generate data for subcategories, because that's exactly what we want. For every category we want 100 subcategories. So now to do so, we'll be using this very thing, and what I'll be doing is select ID from counters limit 100, because what we want is we want 100 subcategories for that, for every category. So I'll be using select ID from topics where type equal to 1, right? And now basically I want to have a join of these two. So what I'll do it is I'll put this in bracket, I'll put this other one in bracket. So now this is essentially creating join of these two, but we also have to give names over here. So I'll say topics is name of this and counters. So instead of topics, let's call it categories. Okay, because since we're specified by types is 1, this becomes categories and this becomes counters. So now what over here, while selecting, I can do my ID of my subcategory, or rather my name would need to have mapping of subcategories, topics, this is subcategory, ID per topic, I name it as categories, select from, I'd put yet another select, I'll put yet another select from this, like this. So select categories dot ID, comma, counters dot ID. Okay, so our categories dot ID become category ID and our counters dot ID become counter ID. Okay, so now my subcategory, in order to give it like a unique identification or something in the name, making it explicit, I would name it as category ID. So I'll be converting subcat hyphen category ID, and I'd be capping it with, so I'll be concatenating it with counter ID. Okay, and now I can use this category ID as my parent key, right? So now effectively what I'll have from here is this two thing would run. First of all, it would take in all the categories out of it and join it with all the counters out of it, with all the 100 counters out of it. So since we have put a limit of 10, it would take all the categories, which are 50, it would take 100 counters. So 50 into 100, right? So it would have 5000 rows over here. And now it would do a select of, it would do select from this thing, and it would say categories.id as category ID and counters.id as counter ID. And now we'll be using this category ID and this counter ID in order to do a select, which in turn goes to insert. So now I'll be doing a select of concatenation subcat counter ID and category ID. So this becomes my name of the subcategory. Parent ID becomes category ID. So whatever the category ID comes from the join, that becomes my parent ID. And type is 2 because this is subcategory. And this, all of this goes into insert, right? So if I do just this, I run just this and see this in action, and then we'll run this again and put it under insert. So if you see over here, the output is here, category 50000, right? And then it has category ID as 50 and this as 2. So this becomes my subcategory whose category ID is 50. So this is the child of 50th category, or category whose ID is 50 and this type is 2. So I'll be putting, and similarly this we would have close to 5,000, we'll have exactly 5,000 rows for this. So it creates mapping of all the categories to also it goes to 0 over here, checkout category, it goes to 1 and then it again starts from 50. So for every single subcategory that it has, it would, so for every single category it has, it would create, it would have an n square join from that and it would generate the value. And now I'll put this in insert, and when I run this thing, we'll see how it does. Running the insert statement, it inserted 5,000 rows in 560 milliseconds. That's it. That's all it took for us to perform an insert. Now, in order to insert topics, what we want to do it is similar to how we did it for subcategories. We would do it for topics. So let's say we have topics, we have topic, and instead of picking categories, we would want to pick subcategories. Subcategories are the one whose ID, whose type is 2, and we want 1000 from counters, right? So because we want 1000 values from counters. So this join would create 5,000 subcategories were there. 5,000 into 1000 will give you 5 million. So this output of this join would be 5 million rows. We'll be picking in subcategory ID from this, and we'll be picking subcategories ID as this. We'll be using subcategory ID and a counter ID. This becomes subcategory ID. That's it. So now this is exactly very similar to how we generated subcategories, right? So taking join, amplifying using joins, and then creating a select on top of it and just formatting it with respect to our required format for insert. And the type of this would be 3. The parent of my topic is a subcategory ID which comes from here, and I can just run this insert and see this in action. So now when this query is running, it would take close to a minute for it to execute, and once we have it, we would see it inserting 5 million rows into the table, right? So after going through all of these 3 explicit steps, where first we inserted categories, then subcategories, and then topics, we have seen that we can amplify using just one helping table, which is counters, and while doing so we have populated 5 million rows using just SQL. So this is a very neat trick where we used insert along with select such that output of select goes into insert, and we have used joins to amplify the reach, because for every one item we need 100 others or 1000 others, right? So this is something that joins gives us. So now this query is still running. It would just take a minute or so, and then once this is done, we would see an output and we would open the table topics to just see on how it has actually inserted the value or not. So just waiting for this to complete. It take 1 minute 11 seconds is there. Will take just 10 or 15 more seconds. But here the assumption that we played around was having a counter table having values from 000 to 999, right? So that's the only assumption that we made. The query's execution is complete. We have created 5 million rows affected, or basically created, in just 1 minute 22 seconds. That's it. That's all it took for us to insert. So now if I refresh topic table, we would see that it would have all of these rows, and I can just apply where clause and see that it indeed has generated this thing. So what I'll do is I'll apply type equal to 2, type equal to 3, because that's what we inserted. We inserted topics. We would see topics being inserted over here, and say topic 64 something. Here it is, topic 64000, parent ID is 64, type is 3, right? So this is how you can generate an entire topology of categories, subcategories, and topics having 5 million rows and under 100 seconds. So just to show that it indeed takes less than 100 seconds, let's just drop this entire table. Instead of dropping, let's just truncate the table. Truncate topics, and once this truncate is done, what I'll do it is I'll run insert statements that inserts categories, subcategories and topics. And here we'll see the time on how long it takes for us to put to ingest 5 million rows randomly generated with this very special requirement of having a taxonomy structure in less than 100 seconds. So this is still running. So meanwhile, what we'll also do it is we have this counters table, right? We assume that we'll have counters table with us. Now this counter table is actually very important because you can't because counter table determines how your amplification would work, right? So since you need maximum of 1000, you need to have 1000 entries in the counter table. So if you see the counters table, it has 0001, 001 and so on. So how will you put all of these values, or how will you put all of these things into this table? So for that we use again joins to amplify. A very peculiar structure of digits is so if you see the numbers from 0 to 999, it's basically the combination of every digit with every other digit, and it's like basically 3 times join, right? So what I've done it is I've created a table digits having values like 0, 1, 2, 3, 4 up till 9, and then in order to insert values into counter, all I've done is I've taken 3 joins. So I've made joins from digits to digits to digits, and my output is just concatenation of the counters. So since these are digits, it has just single digit value, which is 0, 1, 2 till 9, and when I do a concat of that, it gives me 000, 001, 002, 003, 009, then 010, 011 and so on and so forth. This way it generates 999. It generates basically 1000 values. And similar to other steps, I have used this select to ingest data using insert. And yeah, that's how we generate counters table. Right. See, now the entire process is completed. It took 1 minute 23 seconds only. So 60 and 23 is 83. Yeah, just 83 seconds to populate 5 million rows with this particular taxonomy that we are looking for. And for counters, let's just see this in action quickly before we wrap up. So what I've done it is I've created a table called digits. Digits has value 0 to 9 as shown there. Let's just open. Yeah, so digit has value 0 to 9. Now what I'll do it is I'll explicitly run a select statement, a select d1 select star from digits. I'll say d1 and I'll do d1.id. Okay, so this would ideally print all the rows of digits table, right? And now if I, okay, these are the rows, yep. So now if I do join with digits d2 and I say select d1 id, d1.id and d2.id, what I'll effectively be getting is 100 rows from 0, 0, 0, 1, 0, 2 and so on and so forth, or rather 9080706050201000, then 9181716151. So we get 100 rows out of it. So now since we want to generate 1000 random value 1000 values, so from 0002 let's just, so here we get it in 2 columns, right? First one is d1 d2. We just run a concat over this and put d1.id d2.id within that. So this way we just get output as one column where the values of the corresponding cells get concatenated into one. So we get 90807060 and so on and so forth, right? Similarly, we'll get all the values 09192939 and 99, right? So we get from 00 to 99. Now if I were to pull this off for 00 to 0000 to 999, I'll add one more thing, one more digits ka join, and then I'll run d3.id over here. And once I do this, what I'll get is I'll get 1000 rows. It's running. What I'll get is, I see, it starts from 090190290 and so on and so forth, and it will go till it will generate 1000 rows from 000 to 999. So 373, 473, 573 and so on and so forth, right? So this is how we can generate random. So we generate 5 million items in a taxonomy using just SQL. If we were to do this using any Python script or JavaScript, and if we do just insertion of one row at a time, it might have taken us days, if not hours, to do that. And if we would have even done it batches, we would have to keep track of all the inserted IDs and whatnot. It was much easier for us to do this using SQL, and obviously the time taken for us was like literally less than 2 minutes, right? So yeah, that's all I wanted to cover. I'll basically put a link to a public gist or an article in the description. You can check the script out and try it on your MySQL server, and let me know how that goes. So basically that's it all from me for this video. I'll see you in the next one. Thanks a ton.